project due today?
Oh snap, the project's due today!
I'll be there soon, I'm coming! Oh, yo, dude!
Yo,
what are you doing?
I'm going to school, what are you doing?
Who's that way? Sorry.
No way, it's this way!
No, it's that way. Oh, what's up?
What's up?
What are you guys doing?
We're gonna get to school to do our project. We have to present.
We don't have to present at school. We have to present here. Oh shit.
Oh yeah! Hey guys, my name is Mark and I'll be talking about quantum locking. Quantum locking is a process by which a superconductor is locked in place within a magnetic field as a result of the Meissner effect. The Meissner effect is a phenomenon in quantum physics in which a superconductor negates all magnetic fields inside of the superconducting material. It does this by creating small currents along the surface of the superconductor, which has the effect of cancelling out all magnetic fields that would come in contact with the material.
Hey guys, I'm Christian. Adding on from Mark's segment, quantum locking is also quantum levitation and flux pinning. It is a process where scientists use quantum physics to figure out how to levitate an object. This object consists of a superconductor which contains a metallic alloy, which is within a magnetic field. This object is submerged in liquid nitrogen. From there, it repels off the magnetic field and it's able to lock itself within the levitation. Thus being affiliated with the Meissner effect, where the object tries to balance itself out through magnetic repulsion, thus being locked. This object is also known as a superconductor. A superconductor is what helps electrons flow freely. And as these electrons are flowing freely, and as it gets closer to the magnetic field, it creates a current on the surface of the superconductor, thus cancelling out the incoming magnetic force.
The Meissner effect was discovered in 1933 by German physicists Walter Meissner and Robert Ochsenfeld. The lead researchers in the Tel Aviv University have made the quantum locking phenomenon into a viral video. The YouTube video went viral in 36 hours. Here's the YouTube video right now.
Quantum locking, the superconductor is locked in space and it stays wherever I put it.
You're probably wondering, are there any research plans for the future? Unfortunately, there will be no hovercrafts, no hover cars, not even hover shoes. But apparently in Asia, there will be a train that will be suspended within the air. But for now, scientists have declared an actual frictionless bearing, where the bearing will actually float within the housing.
In my opinion, and thinking of the ways they can use this technology, I'm a little afraid of the things they are capable of doing. But in a way, I'm very curious on how far they can get with this technology. I wonder if they can get bigger objects to get locked in the air without any bad repercussions.
Well, my opinion about this topic is that it was very interesting to research on, but it is also overwhelming and upsetting knowing that there will be no hovercrafts and hoverboards for a while. But hopefully scientists can and create a superconductor that doesn't have to operate under low temperatures. This way would be a step closer to having those hoverboards and hovercrafts.
Hello and good afternoon. My name is Mark and we'll be talking to Brian Green today. Hello, Brian.
Hello, Mark. How are you today?
I'm good. How about you?
I'm pretty good myself.
So, Brian, tell me about yourself.
Well, I was born on February 9th, 1963 in New York City, New York. My childhood was rough to say the least. I dropped out of high school and did some soul searching. During that time, I realized that physics was my calling. Being a high school dropout, I knew my chances of getting into university were very slim, but I gave it a shot. Miraculously, I got into Harvard in 1980. There I completed my undergraduate degree in 1984. From there I went on to earn my doctorate in Oxford University as a Rhodes Scholar in 1986. With an undergraduate degree and a doctorate under my belt, I pursued my calling and joined the Faculty of Physics in Cornell University. That was back in 1990. In 1995, I became a full professor in Cornell. In 1996, I became a professor of physics and mathematics at Columbia.
What kind of physics do you dwell in, Brian?
Well, I'm a theoretical physicist, but you probably already know that. I specialize in string theory and superstring theory.
What kind of contributions have you made to the scientific community?
My most notable contribution to the scientific community would probably be my comprehension of the so-called Calabi-Yau manifolds. This type of manifold is just one of the many odd shapes one may encounter while studying string theory.
And to close the show, can you tell our viewers out there something about the real Brian Green?
Let's see. You know the show The Big Bang Theory? Well, I appeared on the show where I talked about my book, The Hidden Reality, now in stores, as the character Sheldon Cooper mocked my work. Also, during my time at Oxford, I studied piano with a certain famous concert pianist, Jack Gibbons. Maybe you might have heard of him.
So thank you, Brian, for talking with us today.
It was a pleasure.
And to all of you watching this, have a great afternoon and enjoy the rest of the presentations.
Shit, the fuck you do? I can't swear.
Damn it!
Mark, you're high. It's really dark in here. I don't want to. That's okay. Batman. Batman. Batman.
It's recording and go.
One of the many.
The Meissner effect was discovered in 1933 by German physicist